Right, so we're looking at permutations. Permutations is kind of another word for arrangement. So we're starting to think about how can we arrange things? How many ways can we arrange things? So I think the best way to explain this concept is with a problem to see why we need the concept at all. So the problem is how many ways can six elves, probably elves, be arranged on a shelf in any order? Well, let's have a think. If we sort of draw some boxes to represent the six positions on the shelf, what we could do is we could say, all right, in the first position, we've got six elves to choose from, right? So we could put one of the six elves there. So we've got six options. So this box or this spot on the shelf has six options. Then in the next spot where you've chosen one of the elves, so the next spot you've only got five options. And then you've only got four options because you've selected two already. And then you've got three options, then you've got two options, then you've got one option. This is actually a concept in maths that has a name. So what we're actually going to do is we're going to multiply 6 times 5 times 4 times 3 times 2 times 1. And that's what's known as factorial. So sometimes on your calculator, you might have seen the exclamation mark. So 6 factorial, we would say, is equal to 6 times 5 times 4 times 3 times 2 times 1. And if you're wondering why I'm multiplying, I'm going to put a link below for what's called the multiplication principle in combinatorics. So definitely go have a look at that. But basically, there's going to be 6 factorial ways to arrange those 6 elves on the shelf, right? We can probably work it out. It's probably not a huge number. 6 times 5 is 30, times 4 is 120, times 3 is 360, times 2, 720. 720 ways to arrange 6 elves on a shelf in any order. Okay, but what if we start putting in restrictions? So say we've still got the same 6 elves. How many ways can those 6 elves be arranged, but now into 4 spots on the shelf? So you've got 6 to choose from, but there's only 4 spots. So 2 elves are going to miss out. And so what you do again is you set up your boxes, but in this case, you've only got 4 spots. So again, in the first position, you've got 6 options, 6 elves to choose from. But then one of the elves is chosen. So in the next position, you've only got 5 options, then 4 options, and then finally, you've only got 3 options. So we can work this out. It's obviously going to be less than 720, our answer. And what we're going to say is this is actually this notation here. And how we would read this is n permute r, or in our case, 6 permute 4. 6 elves to choose from, 4 spots. So 6 times 5 times 4 times 3 is going to be our answer. And before we get that, let's just think about what that is. That's 30 times 4 is 120 times 3 is 360. It's 360 ways to arrange 6 elves into 4 positions. Okay, we're going to just formalize this a little bit more. You might have realized that basically we just don't have the multiplied by 2 and then multiplied by 1 at the end. So one way to think about it is we divided by 2 times 1. Okay, and then this is the sort of the big leap here we need to make a little bit. This is the rule for n permute r. On the top, you can see we've got n factorial. We've got 6 factorial, which is what goes on top here. So we've got n, so we've got on the numerator, we've got n factorial. All right, in the denominator, we've got n minus r. Well, let's think about our example. What was n minus r? 6 minus 4 is 2. So in the bottom, we have 2 times 1, which is 2 factorial. So in the denominator, we have n minus r factorial. And that basically just cancels out those last parts that you're not interested in because 2 of those elves are missing out. There's one way you can think about it. So that 2 is going to cancel with that, and the 1s cancel out as well. So you're just left with 6 times 5 times 4 times 3. So there you go. That is what permutations are all about. Later on, we're going to talk about combinations, and they can be confusing. So just keep in mind that what we spoke about here is permutations. And yeah, it's basically how many ways can you arrange a certain number of objects into a certain number of spots. Okay, here's a problem you can try. Let me know in the comments, or otherwise, how you go. How many ways can 10 people be arranged into 6 chairs in any order? They're very similar to what we just did. Probably going to need your calculator to work some of these out. So good luck with all your studies, and I'll see you soon.